Let's look at one more example. Solve 3 over x minus 2 is greater than or equal to 1 over x plus 2. Now step 1 is to solve the related equation, which would be 3 over x minus 2 is equal to 1 over x plus 2. And note that -2 and -2 are excluded values. If x is 2, I would have 3 over 2 minus 2, which would be 3 over 0, and division by 0 is undefined. If x is -2, -2 plus 2 is 0, I'd have 1 over 0, which is undefined. So 2 and -2 are excluded values. That means that 2 and -2 are excluded boundaries. So excluded values become excluded boundaries when you solve inequalities. Now to solve this inequality, I need to clear fractions. To clear fractions, I need to multiply both members by the common denominator. So the common denominator is going to be x minus 2 times x plus 2. So I multiply the left member by the common denominator, and I multiply the right member by the common denominator. So I multiply both members by the common denominator. Now we can reduce, and I'm left with 3x plus 6 is equal to x minus 2. Or I have 3x plus 6 is equal to x plus the opposite of 2. Add a -1x to both sides, and I get 2x plus 6 is equal to -2. Add a -6 to both sides, and I get 2x is equal to -8. Divide by 2, I get x is -4. So -4 is an included boundary. I know it's included because we started with greater than or equal to. So step 2 is to put the boundaries on the number line. Zero, so here we have 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. 2 and -2 are excluded boundaries. So I put an open dot at 2, an open dot at -2. -4 is an included boundary. So I put a solid dot at -4. Step 3 says to choose checkpoints from each region. So I need to pick maybe -5, -3, 0, and +3. Now I need to check into the original. The original was 3 over x minus 2 is greater than or equal to 1 over x plus 2. Let's check -5. I have 3 over -5 minus 2 greater than or equal to 1 over the -5 plus 2. A negative 3/7 is greater than or equal to a negative 1/3. A negative 5 plus a negative 2 is negative 7. 3 divided by negative 7 is a negative 3/7. Negative 5 plus 2 is negative 3. 1 divided by negative 3 is negative 1/3. Now, of course, I need a common denominator, which is going to be 21. 7 goes in 21 3 times. 3 times negative 3 is negative 9. 3 goes 21 7 times. 7 times 1 is negative 7. Well, negative 9 21st greater than or equal to negative 7 21st is false, because negative 9 is less than negative 7. So this gave me false. Now let's substitute in negative 3. So I have 3 over negative 3 minus 2 greater than or equal to 1 over negative 3 plus 2. 3 over negative 5 greater than or equal to 1 over negative 1. A negative 3/5 greater than or equal to negative 1. Now this is going to be true, because a negative 3/5 is greater than a negative 1. So that gave me a true region. Now we'll check 0. And remember, we're checking into 3 over x minus 2 greater than or equal to 1 over x plus 2. Trying 0, that's going to give me 3 over negative 2 greater than or equal to 1 over 2, because we're checking the 0. 0 minus 2 is negative 2. 0 plus 2 is 2. A negative 3/2 greater than or equal to 1/2 is false. So we have a false. Now we check 3. 3 over 3 minus 2 greater than or equal to 1 over 3 plus 2. 3 over 1 greater than or equal to 1/5. 3 greater than or equal to 1/5 is true. And step 4 says shade where you have true. So there's my solution. I can write it in interval notation as starting at negative 4 and including it, and going to negative 2, but don't include negative 2. Union, start back at 2 and go forever.